This is the November 18, 2020 ORION meeting. Mark Littmann will be our speaker. And I happen to know the speaker, a friend of mine, and he always gives fantastic programs. So you picked a good night if this is your first time to come in. I'm David Fields. I'm going to turn it over to our Vice President and Program Chair, Don Spong, to introduce our speaker. So, Don?
Yes. So tonight we're fortunate to have Professor Mark Littmann with us. And Mark is Professor of Journalism and Electronic Media at the University of Tennessee, and he holds the Hill Chair of Excellence in Science Writing and also the CCI Board of Visitors Professorship at the University of Tennessee. He received a BS in Chemistry and Literature at the Massachusetts Institute of Technology, a master's degree in creative writing at Hollins College, and a Ph.D. in English at Northwestern University. He's written a number of books, and I won't go through them all here. You can see the announcement listed, but several of these have won awards. Comet Halley won the Elliott Montroll Special Award of the New York Academy of Sciences, and both were also chosen by the Astronomical Society of the Pacific as Astronomy Books of the Year. The Heavens on Fire, Totality, and Planets Beyond were Astronomy Book Club selections. And he's also actually written a number of plays, including two recent ones on subjects related to astronomy. One was Halley and Newton, and then another one, Little Lessons for Lina, which is about Caroline Herschel, the first woman to be a professional astronomer. Before joining the journalism faculty in 1991, Littmann taught astronomy at Loyola University in Baltimore, astronomy and literature at the University of Utah, and Westminster College in Salt Lake City, and also literature and writing at Northwestern University. In Salt Lake City, he was also director of the Hansen Planetarium from 1965 to 1983, and he wrote and produced 35 planetarium programs, some of which are still being performed worldwide. So with that, I'll turn the program over to Mark, and thank you very much for joining us tonight.
Thank you very much. Good to be with all of you again. Thank you, David Fields, as well. I really enjoy my time with you all at ORION. And I hope this more personal speech will maybe appeal to you, but you can tell me about that later. Let me begin by taking you back to 1951. That's 69 years ago. I was 11 years old. I was living in St. Louis, Missouri. Dad and Mom recently bought a television set. Seemed to me we were the last family in the neighborhood to get a television set. But checking historical records, I found out that fewer than 1 in 4 Americans had a television set in 1951. The picture on our television set was black and white, of course. There were no colored televisions available to the public yet. Also, there were only 2 or 3 channels. You could watch the Howdy Doody show, or you could watch Kukla, Fran, and Ollie, but that was mesmerizing. It was radio with pictures. One day, I turned it on, and there was a white-haired man talking to me about some small town in New Hampshire. He was pointing out Main Street and the drugstore, and there was nothing there. That was weird. I almost turned it off. But here came a newspaper boy throwing newspapers up on people's porches, except that there were no newspapers being thrown, and there were no porches. Then came a milkman in a wagon pulled by a horse, delivering milk to people's homes, except that there was no horse, no wagon, no milk bottles, and no houses. So I watched. I'm not sure I had ever sat still for that long in my life. I was 11 years old, so I was a little embarrassed when George and Emily fell in love. But I was glad they got married. It was a very happy story. And then Emily died. What? I'm not sure I'd ever seen a movie or a television show where the hero died. That wasn't the way it was supposed to be. Then Emily came back from the dead and relived her 14th birthday. And now she saw how she had always taken for granted the love of her parents and her brother George and her brother and her husband-to-be George. It made her so sad that she stopped reliving life. But before she went back to being dead, she said, "Oh, Earth, you're too wonderful for anybody to realize you." And then she turned to the white-haired man and asked, "Do human beings ever realize life while they live it, every minute?" The white-haired man said no. And very soon after that, he ended the play by saying, "There are the stars doing their old crisscross journeys in the sky. Scholars haven't settled the matter yet, but they think there are no living beings up there. They're just chalk or fire. Only this one's straining away all the time to make something of itself. The strain's so bad that every 16 hours, everybody lies down and gets a rest. You get a good rest too. Good night." The screen went dark. Then the credits appeared. They said the play's name was Our Town by Thornton Wilder. I sat there staring at the television set. My life changed that day. For the first time, I realized that life is very short, and the world is full of wonders that we take for granted. You get a good rest too. Good night. Not that night. I had too much to think about. It was time for me to take an active role in pointing my life in some direction. It was time for me to try to appreciate the wonders and the people around me. Did I succeed in realizing life every moment? Not even close. But I tried to appreciate a moment here and there, a person here and there, and I remembered our town. I pointed my life towards science. Then in graduate school, I switched to literature. I wrote my doctoral dissertation on Our Town and Other Plays by Thornton Wilder. Then I went back to science. Remember the stars doing their old crisscross journeys in the sky? I went into astronomy, teaching and writing about astronomy. Day in, day out, I got to study astronomy. And there it was, the same message again. It was as if the universe was sending me a message. There were the stars in the sky. On a clear night away from city lights, it looks like there are a million stars, but the human eye can see only about 5,000 individual stars from Earth. If you use a pair of binoculars to augment your eyesight, the number leaps into the tens of thousands. Use a telescope and the number soars into the millions. There is so much that we don't see unless we look more carefully. Away from city lights, you can see the Milky Way stretching from horizon to horizon. With your eyes alone, it's just a cloudy band of light. With binoculars or a telescope, as you know, you can see that band of faint light is actually millions of stars. And not just stars. There are nebulae, clouds of glowing gas, and other clouds of dark gas. There are clusters of stars, some with 300 or 1,000 stars, some with more than 100,000 stars or more. As astronomers studied the distribution of the stars, nebulae, and star clusters, they realized that we live in a giant collection of stars and nebulae called a galaxy, with most of the stars lying in the disk, which appears to us as the Milky Way in the nighttime sky. If we could climb outside the Milky Way and look back, we would see that the Milky Way is spiral in shape, and our solar system lies about 3/5 of the way out from the center. From our position inside the Milky Way, we can look out and see hundreds of more galaxies. No, thousands, millions, billions. No, actually, more than 1 trillion galaxies in the observable universe. In these pictures, there are almost no individual stars. Each dot you see is a galaxy. And every galaxy has an average of, say, 100 billion stars. So the total number of stars in the presently observable universe is 100 billion trillion. That's the number 1 with 23 zeros following it. There are more stars in the universe than there are grains of sand on all the beaches and deserts on Earth. 1,000 times more. Some people find these numbers depressing. Our universe is overwhelming, they say. They feel small and insignificant. Our sun is a stable and long-lived star, they say, but it's very average in size and just one of 100 billion trillion other stars. Our Earth is a lovely life-supporting planet, but it is threatened by mankind's recklessness, and telescopes have now found about 4,000 other planets revolving around other stars, and about 1,000 of those planets are close to the same size as Earth. We may not be so special, these people say. And think how hostile it is, space itself. Unless you are up close to a star, the temperature is about 450 degrees below 0 Fahrenheit, and there is no oxygen to breathe, no water to drink, and cosmic radiation will quickly ionize your insides. We are small and insignificant, these people say. But is the universe telling us something very different? As we look out into space, we are looking backward in time. Light travels at 186,000 miles a second, the equivalent of 7.5 times around the Earth every second. It is the fastest traveler in the universe. But the universe is very big. The sun is 93 million miles away. It takes light from the sun 8 1/3 minutes to reach the Earth. So when we look at the sun's corona during a total solar eclipse, we are seeing the sun not as it is right now, but as it was 8 1/3 minutes ago. Alpha Centauri, the bright star on the left, is the nearest star to our sun. It is 4 1/3 light years away, so we see it as it was in 2016. The Great Spiral Galaxy in Andromeda, the nearest large galaxy to the Milky Way, is 2.5 million light years away. So we see it as it was 2.5 million years ago. We are looking back in time to when there were apes on Earth and mankind was just beginning to evolve. The most distant objects we see in the universe, quasars, are galaxies in the process of forming. Some are more than 13 billion light years away. We see them because black holes at their centers are torturing the gas spiraling into them and creating the brightest glow in the universe. This picture is artwork. When we see a distant quasar, the bright blue dots in this picture, and this is a photograph, we can be looking back in time more than 13 billion years, long before the sun and Earth formed, not long after the universe burst into existence. The motion and radiation in the universe tell us that the universe was born in a big bang 13.8 billion years ago. Isn't it amazing that the universe tells us how it was formed, and that we can watch the first galaxies forming, even though that happened more than 13 billion years ago? As we look around the universe, it shows us so much more. In the Milky Way and in nearby galaxies, we see stars forming out of nebulae, out of clouds of gas and dust. And in our Milky Way and other galaxies, we see stars die. Stars of moderate size like our sun swell up into red giant stars and then puff out their outer layers. Those gases, glowing brightly, expand like a bubble into space, while the core of the star becomes a dim red dwarf. Other, much more massive stars explode, crushing their cores into neutron stars or black holes and blasting their outer layers into space in every direction. In those explosions, the temperatures reach hundreds of millions of degrees, and some of the hydrogen and helium in those stars is fused into carbon and nitrogen and oxygen, into silicon, sulfur, and iron. These exploding stars have created all the chemical elements in the universe besides hydrogen, helium, and a little bit of lithium. These heavier elements, carbon, nitrogen, oxygen, and all the others, mix with the hydrogen, and out of these new clouds of gas, new stars and new planets are formed, now with all the chemical elements needed for life. And on Earth, and who knows where else, life began. And 4 billion years later, we stare out into the universe and realize that we are made of atoms that were once the insides of supergiant stars that exploded. What is the universe telling us? That we are stardust. We are children of the stars. The stars up there in space, I am related to them. Some of the biggest stars exploded long ago, and in their explosions created the material that gives me life. That's what the universe is telling us. It makes me feel wonderful and grateful and awestruck. And the universe is telling us still more. Not only did star formation and star death make it possible for us to live, but those massive stars made possible all the life on Earth. All life on this planet shares the same chemical basis for life, the same chemical elements bound up into a molecule, DNA. We all share DNA. We all depend on DNA. DNA is found not only in all plant life and in all animal life, it is the foundation, the operating system for all life on Earth. The difference between an oak tree and a blade of grass, the difference between butterfly and zebra, are changes within the basic DNA molecule. In the chemical sequences of the DNA molecule, we are more similar to a redwood tree or to a bluebird than we are different. That makes me feel terrific. I have family everywhere I look. I am kin to baboons and bees, elephants and eels, porpoises and penguins, moss and mushrooms, redwoods and redbuds. So I look out at the universe, admire its awesome size and beauty, and realize that I am part of the universe. The universe is in me. The universe is in you. The universe tells us that it began with the Big Bang, out of which came all the energy and matter in the universe today. And when we look at ourselves and all other forms of life, we see no less a wonder. Each of us has a similar tiny beginning, very different from what we are today. Each of us human beings came from one cell, a fertilized egg. That egg cell divided and divided again, and the new cells specialized, and they grew into you. You are made of 37 trillion living cells. Each of you is made of more cells than there are galaxies in the universe. Each one of you is your own universe of cells. And unlike the stars, each of your cells is alive. And your cells are working together to pump your blood and supply you with oxygen and digest your food and think about your Saturday night date. It's a wonder that our bodies work at all, and for as long as they do. And think about the immensity of the task. 37 trillion cells working together. Maybe the universe is telling us something. Be more understanding when your cells aren't all working properly. Be more considerate of others when their cells are a little out of whack. Don't bash other people's cells. Imagine that a human being is like a Lego set, and that you have to put that human being together piece by piece. You open the Lego box, take out the instructions, and start to assemble a human being. Look at all that spaghetti there. Oh, no, wait, that's not spaghetti. Those are all the arteries, veins, and capillaries in one human being. Lay them out end to end, and let's get going. Laid end to end, those arteries, veins, and capillaries would stretch 62,000 miles. That's 2.5 times around the Earth in one human being. What's that bulbous thing there? Oh, that's the nose. It can detect, and our brain can remember 50,000 different smells. And look, the human assembly kit comes with 2 golf balls. Nope, wait, those are human eyes. They're actually light-sensing parts of the brain. They work sort of like cameras. Good digital cameras currently on the market offer pictures made from about 24 million tiny dots, 24 megapixels. The human eye, by comparison, offers 576 megapixels, 24 times as many as a fine camera. No wonder the human eye can see more detail in a total eclipse of the sun than any camera. The eye can distinguish 10 million different colors. We'll be a while assembling a human being from this Lego kit. But when we're done, we can move on to the more advanced Lego kit, the one where we start assembling a human being cell by cell, including the contents of each cell. Within almost all human cells is DNA, the molecule that provides cells with the instructions for their operation. The DNA molecule is shaped like a ladder that coils like a spiral staircase. Take the Lego kit and dump out all the DNA. But before we coil up each DNA molecule and stuff it into a cell, let's lay them end to end. We'll start with the DNA for just one cell. Before we coil it up and stuff it into a cell, the DNA for just one cell stands 6 feet tall. There are 37 trillion cells in one human being. So if you take all the DNA molecules for one human and lay them out end to end, they would stretch 10 billion miles. In space, the DNA would stretch all the way from the Earth to Pluto and back. The DNA in just one human being. Pluto is marked by that green arrow. Now that we are done stuffing DNA into 37 trillion cells, we can move on to putting the cells together. Look at those stringy gray fibers there. Those are brain cells, neurons. Let's put a human brain together. Each human brain contains about 100 billion neurons. Be a little careful. Those cells are very fragile. When we're done putting together a human brain, 100 billion neurons, if we get it right, that brain's long-term memory will hold 1 billion million separate bits of information. That's the number 1 with 15 zeros after it. That's more information, more bits of information than there are stars in the Milky Way galaxy. In fact, it would be like you memorize the names of all the stars in the Milky Way galaxy and then the names of all the stars in 1,000 more galaxies. That's what the human brain can do if we don't fog it up or kill the neurons. Then, of course, we can graduate to the ultimate Lego kit, where we put a human being together atom by atom. Let's see. There are about 100 trillion atoms in an average human cell. So altogether in a human being, there are 7 billion atoms. The number 7 with 27 zeros after it. There are more atoms in your body than there are stars in the universe. In fact, it would take 100,000 universes of stars to equal the number of atoms in your body. All those atoms holding together to make you. Take good care of them. So out there in space is a universe of vast proportions, and you are part of that universe. But the universe is not just out there. There is a universe in you. You are a universe. Look at the person alongside of you. That person is a universe too. Is the universe trying to tell us something? Each walking, talking person, each walking, talking universe is a thing of wonder. Treat each universe with respect. So that's a quick look at the universe in you. Now, what if we looked at you in the universe? Where are you in the universe? And where is it taking you? Maybe again, the universe has some advice for us. We are on Earth. The Earth is in motion, spinning west to east, causing the sun, moon, and planets to rise and set, as in this time-lapse photo of the stars rising. In Oak Ridge, Tennessee, we are rotating with the Earth at 840 miles per hour. We are going that way. Meanwhile, the Earth is revolving around the sun. It takes us 1 year to orbit the sun. We are traveling almost 67,000 miles per hour. We are going that way. Meanwhile, the sun is moving towards some stars and away from others. And the sun is dragging along with it by gravity all of its planets and their moons, plus the asteroids and comets. Our solar system is moving toward the constellation Hercules, marked by that purple dot, at about 45,000 miles per hour. Our solar system is traveling in the general direction of the bright star Vega, 25 light years away. Vega is the bright dot just above the center. Whizzing along at 45,000 miles per hour, we are going that way, and will be where Vega is now in only 400,000 years. Meanwhile, the sun is in the Milky Way galaxy, along with 200 billion other stars. The Milky Way is a barred spiral galaxy and looks something like this. As the spiral suggests, everything in our galaxy is orbiting the center. Our Milky Way is approximately 100,000 light years across, meaning that if a star exploded on one edge of the galaxy, it would take 100,000 years for the light to travel to the opposite side of the galaxy so that the people there could see the explosion. Our solar system is located not at the center or at the edge of the Milky Way. Instead, we are located about 3/5 of the way out from the center, on the inner edge of one of the spiral arms. Our solar system is orbiting around the center of the Milky Way galaxy at a speed of about 500,000 miles per hour. But the Milky Way is so large that it will take our solar system 230 million years to complete one revolution. Our solar system is going around the center of the Milky Way in that direction. Meanwhile, our Milky Way galaxy is part of a family of about 30 galaxies that we call the local group of galaxies. Here's a small cluster of galaxies like our local group. Our Milky Way galaxy has 200 billion stars, but it isn't the biggest galaxy in the local group. That honor belongs to the Great Spiral Galaxy in Andromeda. It has about twice as many stars, 400 billion. The 30 galaxies of our local group are part of an outlying cluster, part of a cluster of about 47,000 galaxies that we call the Virgo supercluster of galaxies, because the center of that cluster lies in the direction of the constellation Virgo and about 65 million light years beyond. This is just part of the Virgo supercluster of galaxies. And there are almost no individual stars in this photograph. Almost everything you see is a galaxy. The Great Spiral Galaxy in Andromeda is not the largest galaxy in the Virgo supercluster. That honor belongs to a giant elliptical galaxy which has only a catalog number, M87. Instead of 400 billion stars, it has perhaps 10 trillion stars. Our local group of galaxies is moving toward and probably around the center of the Virgo supercluster of galaxies at 1.3 million miles per hour. We are going that way. The Virgo supercluster of galaxies to which we belong, with its 47,000 galaxies, is one of millions of superclusters of galaxies as far as telescopes can see. And all the stars and planets and galaxies and clusters of galaxies and superclusters of galaxies are in motion, responding to the gravity of objects nearby and far away, all set in motion by the Big Bang 13.8 billion years ago. So many different motions in so many different directions. Is the universe trying to tell us something? Something about you in the universe. The universe is taking you in many different directions. Maybe it's okay to go your own direction. Go with what attracts you most. The first part of this talk was the universe in you. The second part of this talk was you in the universe. You know where the universe is carrying you. You know where you are. Now, where are you going? That's for you to decide. Here's a thought about one direction where mankind is going. We are going into space. For 4.6 billion years, the Earth has existed. For about 4 billion years, life has existed on Earth. About 200,000 years ago, Homo sapiens, our species, emerged on Earth. And for 200,000 years, we lived only here on Earth, but no longer. In 1969, a little more than 50 years ago, the Apollo astronauts set foot on the moon. From the Apollo 11 mission, we have this magnificent photograph. Neil Armstrong, the first human being on the moon, took this picture of Buzz Aldrin, his fellow astronaut. It is a simple picture, really, a human being facing forward, looking straight into the camera. Yet we cannot see his face. Instead, in his visor, we see a reflection of the lunar module, the scientific equipment, and his fellow astronaut. We see in this one astronaut standing for the first time on a new world, a reflection of the ingenuity and teamwork of people back on Earth who made this moment possible. Tranquility Base, the moon, July 20th, 1969. The Apollo 11 astronauts left there a trail of footprints, perhaps a trail for us to follow. There is no air on the moon, no wind, no rain to erase those footprints. Those footprints are still there. 100, 1,000, 1,000,000 years from now, our descendants will come in reverence to stand on the great dark lava plain called Mare Tranquillitatis, to look in silence and in awe at Tranquility Base, the curious ancient scientific equipment, but most of all, the human footprints still present after 1,000,000 years. And they will know that this is where it began, where mankind was born anew, that this is indeed a cosmic monument sacred to the beings of Earth. For here, on the edge of the celestial sea, man took that first fateful step and found himself to be a creature, a being, a citizen of the universe. That's the universe in you. That's you in the universe. And you venture forth knowing that you carry the universe in you. In 1951, when I was 11 years old, one day by accident, I saw some images and heard some words on television that changed my life. Near the end of a play called Our Town, Emily asks the stage manager, do human beings ever realize life while they live it every minute? And the stage manager says, no. Although he says some people do briefly, occasionally, maybe we might too. And then the stage manager closes the play, and I close my talk by saying, there are the stars doing their old crisscross journeys in the sky. Scholars haven't settled the matter yet, but they think there are no living beings up there. They're just chalk or fire. Only this one is straining away all the time to make something of itself. The strain's so bad that every 16 hours, we all lie down and get a rest. You get a good rest too. Good night.
Thank you, Mark. That was really something.
Thank
It covered
you.
a lot of ground in terms of space and time, and the
That's
connectivity.
great.
Yeah, the connectivity is there in the strings of matter and dark matter between our galaxies, and we see the same patterns in our neural patterns. But there's a gap there. We don't really see those patterns of connectivities between individuals quite as much. Want to comment on that?
Sounds like you're way ahead of this talk. You're already into yet a better region, a more important one.
I think everybody's kind of trying to put this in perspective. It's a lot to cover. The lecture is interesting. Did you put this together for classes? Did you put it just together for us in terms of broadening our perspectives?
I put it together originally, a slightly different version. This is an evolved version for a university that asked me to give a talk. And I wanted to try to, so often when we talk about astronomy or we talk about biology, we just kind of confine it to the findings there. And I was thinking to myself, why does it affect me as much as it does? I mean, I really feel keenly, just as you did, about neural patterns in the connections and so forth. And I was trying to put my finger on it, and it reminded me of that time when I was 11 years old and saw a play on television. And I'm waiting now. I was trying to make sure that I could expose my children to that play at just the right time in their lives. I don't think I succeeded. Now I've got grandchildren, but I may not live long enough for them to get old enough to appreciate it. But see, one of the other things that we can all look at is, what moments in our lives changed our course, changed our attitude toward things. When did when did something happen that set us on a different course?
Well, Mark, I just want to comment and say that was a great job, interesting from beginning to end. It had my attention. So great job on that, putting the pictures along with the lecture.
Thank you so much.
This is John Rather. I want to thank you too. I think it was a beautiful talk, and it's really what astronomy is all about. I happen to have a PhD in it myself, and I happen to be 2 years older than you and remember some of that. And I even have a son who acted in our town.
Oh, no kidding.
Yeah. So you spoke to my soul, and I think these are things that are quantitative and that everybody should think about. Thank you.
Thank you.
Mark, I want to ask you something. Tell me what you're going to do after this. Are you going to, because we're going to get you back, so a little bit of a hint of where you're going at UT and what you think astronomy is going to be doing, because astronomy is it's taking some hits. Where's the James Webb Telescope? Where's Arecibo? Do we have to leave it up to the Chinese?
Yeah, and I don't know the answer, and we ought to hear from you on answers to that. Thank you. I have other things that I can talk on. I'll tell you what I'd really love to do one of these days, but it runs a little long, and that I'd love to share the Halley and Newton play with you. You've had before, years ago, part of the play about Caroline Herschel, the first woman.
Telescope for little Lina.
Yeah. This newer play is about Isaac Newton and how he finally published his work demonstrating the universal law of gravitation, which he wasn't going to publish.
So this was Principia?
Right.
Had to be coaxed out of him. He was a reluctant writer.
Well, he was in a big feud with the Royal Society, and he would never probably have gotten around to publishing it because he was always fearful that Robert Hooke and other people in the Royal Society were going to claim that it was their idea and give him fits about who really did it. And so he wasn't going to publish. And it could easily have been that we would not have heard of Newton except as a footnote in history because he was the first to build a reflecting telescope. And he sent it to the Royal Society, and Robert Hooke claimed that it was his idea and he had thought of it first and had built one himself and so forth, and made Newton so furious that nobody heard from him for about 7 years. But there was a new young scientist who had just been inducted into the Royal Society, and that was Edmond Halley. He was trying to solve the same question that everybody of the day was trying to solve, and that is, how can you predict where the planets are going to be in the sky? Oh, you could do it approximately, but you couldn't do it exactly. They just couldn't do it. They didn't have the right concept for it, and they didn't have the right mathematics. Everybody had tried in the Royal Society that could handle mathematics and could handle astronomy. And so Edmond Halley thought, well, he had heard that there was this smart mathematics professor at Cambridge. Maybe he had an idea. And so he went off and asked Newton. And what happened after that, you would never believe. We all know about the great publication of the Principia, maybe the single greatest book in the history of science. But it almost didn't happen. And for sure, it wouldn't have happened without Halley. It just never would have happened. And so that's the story I try to tell. I'm not sure it will work, not sure it'll be fun. You may well go to sleep and you'll never speak to me again, and I'll never get invited. Those are the risks.
We'll finish the official program. And thanks to you all. And many, many thanks to our speakers.